what you find is that from here on, the only thing that you should only be learning would be algebra with exponential and logs. Most of the time, now that you've learned chapter 3 with me and you learned chapter 1, you should be able to do graphs of exponential logs and any other graphs from here on. So you know up, down, left, right, wide, thin, reflection, dilation, those things you should know sort of much better now. And that's what exercise 5A is really all about. So if you've got your head around that, you know, you can do just a few questions and try to move on. It's more about the algebra now, if you remember how to solve exponential equations. That's the main thing you want to take out from chapter 5. Okay, so here we go. Let's do the first exercise, 5A. This is your exponential graph. What are the properties of an exponential graph? There are two properties that you must know and you have to show as part of study design.
The horizontal asymptote.
It has a horizontal asymptote, which is where? Horizontal line asymptote on what equation? What is the equation? Where is it at? Yes, so your whether it's 2 to the power of x or y equals e to the power of x or y equals 3 to the power of x, they all have a horizontal asymptote at y equals to 0. When they ask you to label your asymptotes, you must either use dotted lines to show that it's on. Don't do it as messy as I have just done. But you must label the equation. Okay, so it's not good enough just to write 0. Must write y equals 0 next to it somewhere, or if you want to be more accurate, just write asymptote or horizontal asymptote or asymptote y equals 0. Yeah? So you got a horizontal asymptote y equals 0. Can someone explain to me why? How do we know? Why is there a horizontal asymptote? Why? Someone explain to me. Leah?
If you raise something to a power, you can't get a negative number. If you're doing
So what happens if I raise it to a negative power? So 2 to the power of negative 1. Would that be a negative number? Yep. What fraction is it? Fantastic. This becomes 1 over 2 to the power of 1. So if I change it now to 2 to the power of negative 2, this becomes 1 over 4, which is 2 squared. What you can see is if I increase it in the negative direction, so if I continue on the x-axis, so if I change x to become a negative, the larger it becomes, the larger this number becomes. If this number becomes larger, so 2 to the power of 10, which means it's negative 10 here, then you get a larger denominator. You get a larger denominator, you're taking 1 and you're sharing it by a very large number. Of course, it's very small, okay? But that's the point. Because it's so small, you can keep sharing it. You can always divide numbers. That's why it never passes 0. You can always divide it. Divide in 2, divide in 2, divide in 2, divide in 2. That's technically what base 2 means. Okay? Whereas if you went the other direction, if I asked you now 2 to the power of 2, you can see now positive number or whatnot. This now becomes 4, and then this becomes 8, 16. So you can see it exponentially grows where it doubles. So here was halving. Half, 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 half. This is double, 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 double. And you can keep doubling infinitely, or you can keep halving it infinitely. Yeah, that's why there's an asymptote at y equals 0. But for all the equations I just read up here, there's also one more property that you must label when you're sketching. So we've got an asymptote. What's the other one? Y-intercept. Okay, y-intercept usually as its own property, it is always crossing through 1. So it doesn't matter if it's 2 to the power of x, 3 to the power of x, 2 to the power of negative x, it will always pass through 1. But it's not always the case if you do some transformations to it. Because when you have x equals to 0, that's how you find the y-intercept. When x equals 0, anything to the power of 0 is 1. Yeah? Okay, so that makes sense why you always have intercept at 1. But the only times when that change, when would that change? How do you make sure that you don't have a y-intercept at 1? I can think of translations. Okay, so you can have a horizontal translation, you move it to the left, then it shifts the graph to the right or left, then that just makes it, the y-intercept will change. If you move it up or down, the y-intercept will also change. Yeah, but if you dilate it, it wouldn't do anything, which is what this is. You can change the base, Or you can put a 2 there, and it won't make a difference. You can put 2 to the power of 2x, 3 to the power of negative 2x. You can put 3 times 2 to the power of 5x. It doesn't matter. Okay? Because at the end of the day, it's just a dilation. It's only when you do a translation. So those are the things that you're going to pay attention to when you're answering questions with exponential and logs. There's only 2 properties there. There's going to be an asymptote, and there's going to be a y-intercept, or in the log case, there'll be an x-intercept. Okay? Was that easy? Cool. Let's have a look at some transformations, and I'm going to get you to think about the equations and picture what it looks like. Because remember, methods is all about how well you can picture the graph. The better you picture it, the better you'll answer it. Okay, so domain, range, whatever that is, yeah? Let's have a look at my GeoGebra graph. So I've got a function. It's e base e. I'm going to change, so currently if we zoom in and we have a look, you can see that there's a y-intercept at 1. Okay, so there's a y-intercept at 1 and there's an asymptote here. Now watch as I change, again, dilations, I can change my A. So I can change my A, doesn't matter, the dotted line, the dotted blue line is the original. Okay, so when I increase it to 7, if I, oh, wait, I'll just put it back to 8 here, actually. What's the 8 doing again? What do we call that? 8 times e to the power of x. So e to the power of x is your blue line. That's your original one. E to the power of x. By putting an 8 in front, what am I doing? What kind of transformation is that again? Yes, it is dilation factor 8 because you're multiplying. Remember, this was y equals to e to the x. So when you put 8 on it, what you're saying is for every y value times it by 8. Okay, so I'll just show you what I mean again. What I'm saying is if your original equation was y equals e to the x, then what I currently have here is 8 times y. So that's all my y values, because that's what e to the x is. E to the x is equal to y. So all my y values are multiplied by 8. So if you think about the graph, every y value here is multiplied by 8. So logically, at this point is 0, 1. If I multiply this by a factor of 8, you should expect there should be an 8 up there. So that should be my y-intercept. So let's check that. Okay, so let's see the difference between a vertical dilation, meaning dilation in the y, okay, or from the x, okay, in the y direction, or from the x and from the y. Yeah, so let's have a look at the difference. Watch, if I pull this up, look at that. It's getting close, and voila, right, that spot there. So that makes sense, because you're saying for every y value times in the y values by a factor of 8, which makes sense. Why? You get a y-intercept at 8, because you're changing that value. But watch what happens when I change the 2x. See, if I change this right here, if I change, I'll put this back to 1, and I want you to see, watch when I change, oh God, 1. Watch when I change the dilation from the y-axis, meaning I'm affecting the x values, right? Watch this. I'll change it to 8 as well. Still multiplying by a factor of 8, well, in this case 1/8, factor of 1/8. You can see when x equals 0, it still is at 0, 1. Well, what am I affecting? I'm affecting my 8s, or my x's. So anything that was, I don't know, when it's 1, it should have been at 2, then take that value. So before 2, I'm now dividing 2 by 8. I mean, times 2 by 8, so it becomes 16. Okay, so 1/16, it gets smaller, 1/16. Okay, that's why when you put an 8, when we learned in chapter 3, it's a dilation of factor 1 on 8 from the y-axis, so it actually shrinks it. And that's what's happening. You can see it's shrinking. Yeah. Whereas if I change it to a fraction, you'll see it gets wider. So if I change it to a fraction, so this is 0.75 is 3/4, half. You can see how it gets stretched out, and that's why we say it's a dilation from the y-axis. So it's stretched horizontally, because I'm changing all the x values, whereas before I was changing all the y values. Okay. So there's my dilations, but you can see the only one that changed the y-intercept in terms of dilation. We said translations, you can move up, down, left, right. So if I move left and right, you can see it changes the y-intercept. Okay, but the asymptote hasn't changed. Left and right doesn't. The only time it changes your asymptote is if I move up and down. True? Okay, so when I put a plus 2.5, it goes up. The asymptote goes up by 2.5. Yeah. So if I put plus 2.5, you can see right here. That's my 2.5. That's 2. That's 3. 2.5. That's where I want to reach because I've moved every asymptote. Every value is moved up. Okay. And it's there, but I can move left and right, and all that changes my y-intercept. Cool. And you can tell when it moves left and right. Remember, it's what you're changing to the x values. Okay, whenever you change to the x values, when you're adding on or subtracting, that's how you move left and right. So if I move c to -3 and I change this back to 1, there's 1. There you go. This would imply that I am moving the graph up by 2.5. Doing the reverse, we know that this is moving to the right by 3. Okay, so you can see I've taken this graph root here and I've moved it to the right by 3. Any questions there? Good. And then you got your reflections, so you can't forget your reflections. You got your negatives, and you can see it's still in your. It's a reflection is a dilation. It's just got a negative in it. So if I change the negative, you can see this is a reflection in your x-axis. Goes down. Get a negative in front of the function. Negative of the y values. Negative makes it equal this one. If I put a negative on the x, all the x values, so all of these x values here, become that way. So all the positives become negative. All the negatives become positive, so they flip. Yeah, so if I switch the x values and make b negative, and I make it -1, there you go. Okay, so I flipped it upside down and I flipped it vertically as well, so horizontally and vertically in that shape. Okay. But that's what today's exercise is all about. Obviously, you're not going to get something as bizarre as the one I just made there, but ideally I want you to be able to do that. So even if I gave you that with a 2x and a third at the front, I want you to be able to predict what the graph looks like. Most of the time in your textbooks, if you have a look at the questions, I'll show you, they're really standard to me. These are my ones. No, those are my ones. But here you go. See if you have a look at this. It's pretty straightforward. Left by 1, down by 2. Change bases. Asymptote. Negatives. Reflection, but those negatives are on the x-axis, so it's reflection in y-axis. Up by 2, 2 to the right. Down by 1, left by 2. Yeah? That's what I'm saying. You don't get many fractions, you don't get that exposure. So when you're doing your Saxon exams, it's usually a lot of students find that difficult, but if you just keep it in mind to understand what each part does, it doesn't matter what I do to that one, you should be able to do. Yeah? All right, but that's exercise 5A. I just want you to sort of practice through that. Otherwise, have a look at SAC revision. Okay, you just practice this. Practice your CAS. It's very important that you know how to use your CAS. So everything I've taught, define the derivative, knowing how to find the tangent line, completing the square, it's all in your CAS. Try to be proficient with that because they're very useful for these kind of questions. Okay. All right. Anyone seeing students who are away today, like Naz or Banu? I'll just hand this back to you guys. Make sure they get.